We want to simplify each expression by first writing the radicals in rational exponent form. Here we have the square root of 5 times the cube root of 5. Remember, to multiply radicals, we have to have the same index, which we don't have here. But if we write this using rational exponent, it makes it much easier to multiply. And as a quick review, if we want to convert radical form to rational exponent form, the index will be the denominator of the rational exponent, and the exponent will be the numerator of the rational exponent. So for the square root of 5, we need to recognize the index would be 2, and the exponent on 5 would be 1. And this 5 would also have an exponent of 1. So we can write this as 5 to the power of 1/2 times 5 to the power of 1/3. And since the bases are the same, we can now multiply and then add the exponents. So remember, when multiplying, the base stays the same, and then the exponent would be 1/2 plus 1/3. In order to add these fractions, we do have to have a common denominator, which would be 6. So we can multiply this first fraction by 3/3, and the second fraction by 2/2. Notice how this gives us a common denominator of 6. So this would be 5 to the power of, this would be 3/6 plus 2/6. So this is 5 to the power of 5/6. Now, because they asked us to write this using rational exponents, this would be our answer, but we could also convert this to radical form if we wanted to. Again, if we did that, because the denominator is 6, we would have the 6th root. The radicand is 5, and this would be raised to the 5th power because the numerator of the fractional exponent is 5. And 5 to the 5th is equal to 3,125. So we could also write this as the 6th root of 3,125. Next, we have the square root of 7 divided by the cube root of 7. So again, the index here is 2, the exponent is 1, and the exponent is 1 here. So using rational exponents, this would be 7 to the 1/2 power divided by 7 to the 1/3 power. And now that we're dividing and the bases are the same, we would subtract the exponents. So this would be 7 to the power of 1/2 minus 1/3. And again, to subtract these exponents, we'd have to have a common denominator of 6. So again, we'll multiply this by 3/3 and this by 2/2. So here we have 7 raised to the power of, this would be 3/6 minus 2/6, which would be 7 to the power of 1/6. And again, this would be our answer. So this would be our answer in rational exponent form. But if they asked for radical form, again, because the denominator of the rational exponent is 6, this would be equal to the 6th root. The base is 7, so our radicand is 7. And because the fractional exponent has a numerator of 1, this would be raised to the 1st power, so we can leave off the 1. So you can see one use of rational exponents is to multiply and divide radicals that have the same radicand but different indexes.